Hello, everyone, and thank you for joining us for this episode of Threat Talk. I'm your host, Bob Hansman, and today we're going to take a step back from all the hype and look at the reality of our world after almost 2 decades of everybody getting ready to move to the cloud. Now, to help us do this, we've invited Vincent Burke from Riverbed, a network and application visibility and performance company who've been helping enterprise networks making this digital transformation to the cloud. Thanks for joining us, Vincent.
I'm happy to be here.
Now, I think everyone knows this, but I just want to bring it forward in everybody's mind that, the way I look at it is the cloud is really more of a smoke screen, just hiding somebody else's hardware. So what does this mean for those looking to embrace the cloud from, your networking perspective?
So when you first brought that topic up, the cloud is a lie. I thought that was an interesting and polarizing view to take. But I do agree with you, right? So we've always said, right, the cloud is somebody else's computer. Now, there's a lot of convenience with that, and there's also some drawbacks, which I'm sure we're going to hit. We're going to hit on today, right?
Cool.
The observation I'll make first and foremost here, right, is if I take a look at the cloud journey that I see most people go through, it goes somewhat like this. Well, what are our top 10 applications that see the most usage? Well, that's probably 90% of the traffic on your network. For that top 10 applications, there are handy and convenient SaaS versions available, right? We're talking like, ERP systems, we're talking databases, we're talking email, right? We're talking Office applications, things like that, right? So, moving to the cloud in terms of a SaaS environment for those applications is typically straightforward. And then we take a look at what the rest of the enterprise looks like. Well, on average, an enterprise will have, say, 700 applications that are in regular use. But what kinds of applications are they, right? There might be an accounting application used by 4 people. There might be, think about the major banks, right? They have regulator-based applications to make sure that they don't run too much leverage. Those applications, well, they were all pretty much installed in 2009, right after the financial crisis. There's no SaaS versions available, and so migrating those to the cloud, well, that's different, right? You're looking at infrastructure as a service. You're looking at perhaps standing this up yourself. Latency starts to matter. So when you tell me the cloud is a lie, that's where I go, right? Here we're talking about business critical applications in the long tail of application usage in the enterprise, that if they don't work right, the enterprise isn't trading, the enterprise isn't functioning. And for that, the cloud isn't always the right answer. So it's an interesting angle to take.
Well, and from my perspective, I focus on the security angle. So, you mentioned 700 applications, and I think that's an impressive number. I don't think a lot of people even realize that. They tend to think, well, let's see, we've got a couple of marketing apps, they tend to think every department only has a couple. They may have a couple of main ones, but there's all these little things that people use. When you and I were talking about doing this podcast, I went and looked at what I use day to day in just my own job. And, I'm in product marketing. I write stuff. And even for the podcast, I just use my browser. But then I actually have to have 3 different browsers because of different tools require different browsers for them to work. I ended up with 39 apps that I use just in my own day-to-day job. It's amazing. And of course, now we have to secure those. But where for me, the cloud being a lie is that sometimes that security, I need to be lower than the application level sometimes to see what I need to see from a security perspective. So when I move things to the cloud, I no longer have that visibility into the hardware side of things. Now, how does when somebody moves to the cloud, how does that impact your network and performance capabilities?
Okay, so that's an interesting question in and of itself, right? Because if I think about performance in terms of is the application available, is the application responding in time, right? Especially for applications that are not necessarily the day-to-day usage applications, like think HR applications, but also the sort of the unique applications that are unique to an individual enterprise. What I mean by that is like think about car rental, right? So if you're gonna need to manage inventory, and you're gonna need to figure out who's got what car, where it is, what the mileage is, when it needs service, who's got it booked, what you want to charge for it. Well, there's only going to be so many companies that need that. So that's not an application that is ubiquitous, and the performance envelope of that application is not very well understood. So now let's take that back to the cloud and infrastructure as a service and containerization. If we look at the special purpose of why we're building computing systems to support an application, right? It's always because there is a mission the enterprise wants to achieve. How do I break this down and say it a little bit simpler? Nobody ever starts an enterprise and says, boy, I'm going to build that because then I can have a lot of computers. That's just not how that works, right? You say, okay, I know exactly how to run a furniture operation and build furniture really well, and I want to focus on that. You're not going to sit there and think about an inventory control system. You're probably going to build that custom or buy something that almost does your needs. And thinking about the performance and availability of that isn't generally top of mind. So, cloud is a natural place. Okay, how do you make sure that you have engineered the infrastructure behind your application in such a way that you get maximum performance out of it and understand where those bottlenecks are? Well, you do monitoring, right? Which is obviously the business that we are in or have been in for a very long time. It gets harder as we migrate to the cloud. Now, that's not because the cloud is harder to monitor, but it's because we've effectively added a layer to the cake, if you will. The cake is the lie here, right? We've added a layer to it that now adds a level of complexity. For instance, no individual application or part of an application or microservice is overloading the network or CPU capabilities or perhaps IO capabilities of the application that is specifically deployed there. But when you add them together and you don't understand what the underlying hardware is doing, you may very well be exceeding capabilities there, and you are introducing bottlenecks that are not necessarily evident there, right? So as we've moved to the cloud and we've introduced, right, tunnel-based networking, let's call it SD-WAN, but also CASB, right? We've added an entire layer to the cake, spread the application out, and it is much harder to now determine where, if any, slowdowns or bottlenecks start to happen. Does that make sense?
Oh yeah, it does. And I particularly like your cake analogy because I've had more than one experience where I looked at a cake and it's frosted a particular way. It's maybe a nice white cream. And I'm thinking, oh, this is like a lemon or something. And then I cut into it and I have no idea what they put in that thing. It is the most bizarre stuff hidden underneath all of that frosting. And that is another aspect of the cloud. You don't really know what your apps are running on, which is where the performance monitoring that Riverbed does, that's where that comes in so importantly for companies. Because I think people forget the only reason we have computers is because there are business needs, and the computer can help accomplish those. It's all about the business. It's not like you said, it's not about, gee, how much, money can I get for more hardware to rack up so I can brag about how big my data center is or anything like that. It's about how well you're making the business run. So let's go a little bit into, the whole reason everybody goes to the cloud. When everybody talks about the cloud, why did you move your app to the cloud? Why are you now a cloud or a SaaS service? And the vendor will say, well, that's because the cloud promises scalability and performance. They just automatically throw that out like you're just going to automatically get scalability and performance. And since you're in the business of monitoring performance, what do you see as the reality in that when people do this?
So, Bob, I'm going to take you back to my days when but probably before I did my PhD. The network and the internet and compute infrastructure was much simpler there. Okay. And the biggest question we were trying to answer back in the day is, how do I take a specific application, let's say a problem I need to solve. Let's keep it even more generic, right? Like whether this is working on a radio telescope with lots and lots of data coming in, or whether this is a large application where I'm trying to, where I'm collecting customer data and answering database queries, what have you, right? The questions back then were, how do you take an arbitrary problem you need to solve and try to make that problem go faster, knowing that the individual speed of an IO device like a hard drive or a CPU is limited, right? There's only so much speed you get out of an individual piece of memory. So there's a whole science behind how do you build a computer out of hundreds of compute elements and thousands of drives and all these individual memories, and take that one application and we'll scale it, right? And so why am I taking you through this story? Well, a lot of work was done. Back in the day, we were able to prove that arbitrarily parallelizing an application it can't be done, right? Like the problem is intractable. So the skillful art of those building parallel applications always came down to some things that are very simple, right? There's memory, there's storage, there's CPU, and there's interconnectivity, whether that be a network or some fabric, right? Like what have you, right? The question always is, in this application, what needs to be close together because it needs to communicate fast? Because anything you separate by distance is necessarily going to, be slow. So the question always is, what needs to be close together? Where's the bottleneck of this application going to be? And based on that, one can design a parallel computer or compute system or cluster that can handle that, that computation, right? Fluid dynamics, predicting how spaceships are going to flow through space. All these problems are harder than one CPU can solve. So, okay, so when you tell me, okay, Vince, we've got that problem solved today. There's the cloud. There is an immense amount of computational power available. This is not a big deal. He says, well, that's actually not the case. We're still trying to solve the problems. They just got a little bigger. Climate prediction. Think about protein folding, right? These problems are still, you need to understand how the problem breaks down to understand how you're going to schedule that down to, the cloud. And the cloud is cookie cutter. Like, let's be honest about this, right? You can't just rent a supercomputer with a single click, right? Like, you have to break your application down in individual pieces that can run on limited amounts of CPU and memory and have a limited amount of bus to background IO, right? To storage capability. So it isn't sort of a cure-all. We still today need to understand where the bottlenecks are in our application and our performance in order to be able to improve on that, to understand that the backend networking is the problem. The storage, the number of IOPS is the problem, right? We can't find the index on the database is the problem. We need to approach the problem in a smarter way, right? So when you talk about the cloud sort of being like, well, the cloud has scale, we should be good. I say, well, listen, you're still not absolved of understanding where the bottlenecks are in the problem you're solving. And if you know where your bottlenecks are, you need technology to measure how well that is performing, right?
Yeah, and I still get a kick out of the companies that, they all moved to the cloud and performance was one of their big benefits. And when COVID hit and everybody had to work remote, they threw everybody on a VPN. So everybody's communicating back to a single point, and then that point has to go back out to the cloud, and they've just lost any performance benefit of the cloud. But they did it in the name of security, which is, that's what's really good about this podcast. For those looking on one side of your screen, you've got somebody who's looking at it from a security perspective, somebody else on the networking and performance side. And the reality is that, those promises in general, they're right, but you have to look at your specific use cases. And it's not new. This is not new and unique stuff. I remember designing appliances for security purposes, and some of those appliances, IO was the whole purpose behind it. It didn't need a lot of memory, didn't need a top of the line CPU. It didn't do a lot of computation. It just IO. It was just moving data through it. And then you get other things that they need a lot of computational space. They need a lot of RAM to hold files while they do the analysis. This is where firewalls became next-gen firewalls, and why the price went up, because you had a firewall which was all about IO. Now your next-gen firewall is all about computational, and that's why people now have racks of those things, because that's what it took to scale the darn thing. So yeah, these are not new problems. They're just now in the cloud.
So I want to, before we talk proper security, if we think about, because you just touched on a really, really sore subject that I don't think a lot of enterprises have realized have taken them by storm, right? So in the old days, getting the packets from A to B was the responsibility of someone who is a network engineer, right? And those folks generally understood their bottlenecks really well, and they understood what kind of hardware was available to them and understood what kind of links were available to them, and where the data was going to be stored was going to be very important because you had to get to it. Now, in the modern world where there's a lot of work from home, we have software-defined wide area networking, we have abilities to create almost arbitrary sets of tunnels to get us from A to B, and those tunnels are being created in the name of security. So what ended up happening, right, is I now in my laptop have agents that create a tunnel endpoint that have moved the SWIG, the secure web gateway, to the cloud. A tunnel is created out of my laptop to the cloud. Then all my traffic enters that tunnel, emerges in the cloud, where, yeah, the scalability of a secure web gateway is much better, but there's also a lot of people coming together. And, what is the incentive to make that thing too fast? Because it's just, it's cogs, right? It's cost. It costs money to run that, right? Then from there, I now re-enter the network, the internet, potentially having to go back to my data center or to, well, a third-party cloud application that's probably not in the same cloud where that secure web gateway sits, right? So when I earlier talked about adding layers to the cake, that's really kind of what I was taking a bit of a shot at there, right? Because, and in full disclosure, Riverbed sells these technologies as well, right? These various tunneling technologies, and here it is the security side of the business driving the underlying infrastructure overlays, meaning the performance is no longer determined by how fast is the Wi-Fi network here. It's starting to be determined by, well, how fast is that secure web gateway working? How well is that tunnel working? How well is that agent doing in terms of encrypting, right? And has become, in the security power is evident, right? If I can decrypt every HTTP connection and see what the content is, what website is Vince going to, is this data he's allowed to connect to, is this malicious, is it not? Should I virus scan? Should I not? Right? Is it just a Zoom stream or a live stream like this, which we don't have to dig into? I'm getting different performance results depending on which application I'm using. So what do I mean by that? We're having this conversation right now. Everything's running real smooth and real great, and I'm getting megabits per second of throughput, right? The moment I switch to browsing a website or logging into, say, Salesforce, like some application, things slow down significantly because we're inspecting the content, right? And I can't even determine anymore if my network connection is okay, whether or not I'm going to have a good user experience in the end, because there's that whole layer that just got added in the middle. And that's just, you just tricked me off on that topic, and sorry for hijacking that a little bit, but it's become like, that is like an exact example of how it's become so much more complicated.
Yeah, I miss the days when if I'd had a bad performance on Zoom, I could simply, after the session, run speed test and see if it was my site or not. There's so many factors that come into play that you just don't know. And then, I mean, we're now having, entire regions of the country being interrupted, because of DDoS attacks on DNS systems and things like that. And the tunneling that you mentioned, we don't only have all the legitimate tunneling, but, I've run apps that when I was analyzing them at the lower level, one app was creating a couple of dozen individual tunnels for different purposes. And it's like, why don't you just one tunnel? Because the tunnel itself adds a layer of complexity. It requires every one of them has to be encrypted, decrypted. There's processing for every one. Why not just do one? But I think sometimes, these developers moving everything to the cloud, they just throw everything in a container, build a tunnel, and you're safe. And then they can forget the security stuff and go back to programming their apps. They don't really think through the whole performance and security balance that you need to do. It's a dance. And I'm afraid when we start evaluating different vendors to solve our different problems with their different cloud solutions, we have to evaluate, how they really perform in a real world situation. You can't just look at the feature list. The performance sometimes, well, and for us, it may not be life or death, but I've worked with hospitals, of course, with ransomware and things like that hitting them. And their problem is that, doctors now in an operating room, they need to pull up a screen. They need some data on this patient. I guess they are a customer of sorts. But this patient's, their medical history, what drugs they've taken recently. I got to remind myself. And if that takes 2 or 3 minutes to pull up, which I've heard they run into sometimes when they, haven't got a properly tuned network, lives are at stake here. So it's a nasty balance. And I think tunneling is a problem, might even be worth a podcast in and of itself, because I don't think anybody talks about it in any level of detail, because there's a lot of aspects to it. It's not just do you or don't you.
No, and I think that's not just from a performance perspective, right? As I'm going to give you an example in this. The interesting thing about security is I've been an incident responder myself, and I've spent time working in cybersecurity. Um, what ends up happening with layering encrypted tunnels upon encrypted tunnels, right? So, my laptop will create multiple connections. These connections are probably HTTPS. There's probably some secure WebSockets, right, happening in the background. If I'm looking at just one encrypted connection, say my connection to our HR database, right? So I know the endpoints on that connection. I can tell whether packets are being dropped. I can tell whether there's a slow response time. I can measure some things about that one individual connection, even if it's encrypted. Right? I can try to decrypt it. Right? Technology for that exists. But even if I don't decrypt it, I can still tell a whole bunch of stuff about that connection to that backend HR database. Okay, well, that's the starting point. Now, though, once I start entering, for instance, I'm in an office and I enter an SD-WAN infrastructure. Well, there's probably going to be a number of IPsec tunnels in the backend there as well. So now I've got both my connection to the HR app. I've got my Outlook connection to that. I've got maybe a Slack connection where I'm, text with. All those together end up going into one CASB or SD-WAN tunnel, which is probably a DTLS tunnel. So there's no TCP metrics to evaluate, right? It's just UDP. And I can no longer pluck apart which packet is associated with which application. So it becomes much harder to evaluate, right? And this is, you want to talk about things that I spent my my days like worrying about, like how do we still say meaningful things about network performance or cloud performance? Now let's take that a step further to security, right? So you can see why this is hard from a performance perspective. Now let's take a look at security. Well, what if I have malware downloads, command and control channels, right? I have worming behavior, right? Like I have brute forcing behaviors happening. All those are now getting mixed in. They look exactly the same thing as they enter the tunnel from one location to the other, right? So also from a security perspective, encrypting everything in tunnels doesn't necessarily make you more secure, because it also makes it harder to see inside and make a determination whether the behavior you're seeing is expected or unexpected. Does that make sense?
But yeah, and at this point, we're kind of talking about troubleshooting. You gave a few examples of the kind of things that on the security side, we have to monitor constantly, because we know you're not going to find and detect everything before it gets in. That reality flew out years ago. You have to be prepared and constantly monitor for any signs that something got through, because something's getting through. It's just a matter of, can I detect it in time before it does something more, like lateral movement. This is just moving about the network and finding what they want to find to get access to, downloading more tools to do it, exploiting new vulnerabilities when they find, well, hey, I came in on this system, but I need to get into this other system, but it's kind of secured. I need to elevate my privileges or something else. There's so much activity that is going on in the background. Now try and weave and understand and filter which of that activity is malicious and which of it is just one of the hundreds of things that are happening in the background for the 700 apps that you're currently running.
Well, so that the interesting angle, I think, on that question is also an industrial shift that is only ever so slowly happening on that. And what I'm talking about here is the words you just used. How do you detect that, right? Like, and what I know what you're talking about. You're talking about sort of what we've been calling the advanced persistent threat, right? Like those individuals with the time and the skill and the resources to go in, get in, spread, be in, and not get detected, right? So because that's really the trick, right? Like it was, if you should understand most detection technology, you generally know how to avoid getting tripping that detection technology. Those advanced persistent threats are necessarily the ones that can do the most damage, right? Like that's, because they know the asset they're breaking into, right? And right. The funny thing about it is that we're still overwhelmingly looking for technology that can set off the red blinky light and then, okay, well, the bad guy's in, now let's do something about it, right? And one thing I noticed is I was in the security industry before I joined Riverbed, and one thing I noticed is when customers call Riverbed about security incidents, right? It's because it has already happened, right? Something has happened. Somebody got in and managed to fly under the radar. An existing process did not work to catch them. And what are the questions people are always asking? When did they get in? How deep did they get? What other systems were affected? How long ago did it start, right? The why, how, when kinds of questions are being asked by the incident responders, which are sometimes outsourced companies that are being hired to come clean up. And why did I turn to Riverbed? Well, you've been, and I bet, Bob, Infoblox sees the same exact increase coming around. Because, what assets are on the network? How are those assets affected? Who else got connectivity there? Were any virtual machines spun up? Stuff that you guys can see, right? So when I look at that, the incident responders are simply looking for the network flight recorder. What was on the network? What happened? Who communicated? How long ago did this start, right? This is all forensic recall, and none of it has anything to do with a red blinky light detector that went off, right? And that's what I see. And that's where I see most organizations are not yet realizing that putting simple flight recorders in place is probably your best ability to detect, right? Which comes into the cyber hunting, but also minimize the damage of the advanced persistent threat on your network.
Well, and it's also a matter of people tend to think, oh, you need to detect a threat. No, you don't detect a threat. You detect anomalous activity. For example, the whole Log4j, Log4j shell thing, when that was first exploited, most of the early attacks for the first few days were crypto miners. So where would you have seen evidence? It would have been when all of a sudden the performance of your devices is being consumed. They're all running at 90% all the time. What's going on? That's the kind of stuff that, and I want to make it real clear for the listeners here. This is a very interesting podcast, and one I would like to do more often, because we normally have, vendors who are partners in security. We have analysts in security. Riverbed and Infoblox are completely different segments, but together, your networking side and your security side, that's where collectively you get that monitoring, that visibility that you need. You're going to see a lot of clues of that lateral movement of an infection in your networking monitoring tools, your performance monitoring tools, long before you'll see a security indicator.
So I think that's actually, in my experience, the way that most advanced persistent threats are ever found is because someone is looking at a performance problem and says, now, isn't that interesting? Or why is that happening? Why is the CPU at 100%? Why is this router dropping so many packets, right? Like, people are investigating something that isn't quite working right, and they don't necessarily have an indication of, right, like something that might be wrong. Then looking at it, it's like, why are these connections here? Why is it starting so many processes? Like, whatever it may be, that's when it becomes an incident where you actually just trip across, the real problem here. So it's interesting you mentioned that.
Yeah, and well, because I wanted to make sure that I pulled that out, because we're kind of running short on time, and which is, as usual, we run out of time, and so I wanted to make sure everybody understood that the value of this podcast has been a completely different perspective of from your side, which is actually not all that different from the way we need to look at things on the security side. Networking security just need to make those connections better.
Yeah, I completely agree with that. The benefits gained there from being able to collaborate, share tooling, collect telemetry and visibility in addition to detectors, getting lots of different angles of visibility on the network at the same time, right? Not just, okay, I'm collecting logs, I'm done, right? Like, think about what's happening on the endpoint, and not just from a detection standpoint, right? The CPU time example you gave is very pertinent there. What's happening on my networks, right? What's happening in packets, flow data, endpoint data, what have you. That's actually what prepares an enterprise to be able to deal, to hunt for, to remediate after. to get to get back on your feet as soon as possible and to truly prevent, right? So that's really where that's at. That's pure telemetry gathering. Wow. Yeah.
Yeah. Well, we'll have to discuss if we can maybe come back and go into some other aspects of this in more time. But unfortunately, my timekeepers are pointing out we're at time. So Vincent, thank you for joining us today.
It was an absolute pleasure to be here. I enjoyed it.
And I want to thank all of our viewers and listeners for your time as well. So join us next time as we continue our efforts to help you stay on top of cybersecurity and ahead of cyber risks on Threat Talk.